Hello, so let us solve the problem here. So this is the problem actually. So I have an iterated double integral and a double integral on a domain, and the domain is given to me here. Here the limits of integration is also clear. So the y value is going from 0 to 1, but the x goes from y to 2y. And we are supposed to calculate this sum, okay? Of course, one way to calculate this sum is to calculate this integral, finish it, calculate that integral and finish it, and then add up the numbers. But usually, when mathematicians actually design a question, if they design it in that way, and especially when you see the integrands are exactly the same, so there was a purpose behind that. So you need to discover that purpose, otherwise you will be in trouble. Okay, so I need to understand the connection. By the way, if you want to tackle this problem directly, it is not that easy. Let us try to analyze the problem, because you will not learn mathematics unless you know, if you are changing your strategy, you really need to know why you are changing the strategy. So because you know that you might think this is a ready-made integral for me, because you know that in double integral, actually, if you have seen the previous videos, usually finding the limits is a hard thing. You need to go and realize the domain to be able to write the limits of the integral. But this integral has already the limits in place, so you might think that, okay, it is ready-made, so let us just start. But then immediately you realize that is not that easy if you want to immediately and directly attack the problem. Because what you are supposed to do if you want to do it directly, you are supposed to start from that part, and when you finish that part, pass that function to this integral and do it once more. But the problem is that if you want to do it, y is not an obstacle in front of you because the variable is x. Y is a constant, okay, I can pull it out. And then, let me write and then I will clean it. What is left for you here? You will be left with 1 over 1 plus x cubed dx from these two limits, okay? The limits are not that important, but you need to find a primitive function for this function, which is not that easy. By the way, it is not impossible, it is possible, but it is complicated and lengthy. But then, of course, so how you want to do that? You use the method of partial fractions. You factorize this, 1 plus x and times 1 minus x plus x squared, and the partial fraction, you write it as 1 plus x, and then you write 1 minus x plus x squared, and then you write a constant here, but this is the second degree, you write this one. And then by taking the common denominator, you find a, b, and c, and instead of calculating this integral, you calculate this integral plus that integral, which is simpler. But it is possible, I'm not against that, yes, but remember, even after you have done all these things, you have to replace the x's with y and 2y and subtract them. It becomes even more complicated function of y. Then your problem starts again, because now you have to integrate it once more, that complicated function with respect to y. So I hope that I have convinced you enough not to do this. Yes? Okay, so let me just clear it. Okay, so if I don't want to do it, the standard trick, by the way, these are standard tricks. If you study perfectly fine, you'll realize these tricks. So I need to change the order of integration. So here the order is x first, then y. And then by Fubini's theorem, if you understand the domain of that function, you can change the role of x and y, changing the role of the free variable. Here, I started, the free variable is considered to be y, and then x, we want to change the order. Be careful. How can I do that? To change the order, again, you have to understand the domain of the integration first. Okay. How should I understand that? I come here, I set up a coordinate system myself. So if you don't mind, let me start from here. So I set up a coordinate system, x and y. Okay, I come back here. I see the y value is between 0 and 1. So the lowest value for y is 0. Then I go higher and I say y is equal to 1. Okay? But here, this is the x coordinate. the lower limit x is equal to y, and the higher limit is supposed to be x equals to 2y. So these four boundaries will set up for me the domain of this integral. So how should I do that? It is extremely simple, because these are lines, these are also lines. These are horizontal lines, these are oblique lines. So what I do, y equals to 0, of course, is the x-axis. Y equals to 1, let me just draw that. This is y equals to 1. Yes, y equals to 1. I know that the y value is somewhere between 0 and 1. Okay, but let us look here. X equals to y is extremely simple. X equals to y is, for example, this one. This is x equals to y. Yes. I'm sorry. So x equals to y, understandable. X equals to y, or y equals to x, and this point is 1. Okay, but the other one is x equals to 2y. X equals to 2y is also a line which passes through the origin, because 0, 0 fits the equation. And then I give another point. For example, if I put x equals to 2, y becomes 1. So x2, y1. x2, y1 is also the point for that one. Okay, so drawing that would be a little bit harder, so let me take this ruler. So this is the other line. I should have used this ruler from the beginning, I would say. Anyway. Okay, so this is also my line. So if you don't mind, let me continue a little bit more, because that is probably needed. Okay, so here I have x equals to 2y. Okay, now if I ask you, can you recognize the domain? It is simple. Y is between 0 and 1, and x is between these two. What does it mean? It means that x is less than or equal to 2y, that's my upper limit, and greater than or equal to y. Okay, so these are my borders. I want to know the inequalities, so I need to check a point. Okay, for example, I want to know which side of this line is representing this inequality. Okay, for example, I am certain about the position of my point here with respect to this line. The coordinates are 0 and 1. X is 0, y is 1. X is 0, y is 1. Is it true or false that 1 is less than or equal to 0? It is false. So this side is not acceptable, then it has to be the other side. So this shows me that I have to go, yes, to this side. And the same story here. I can check the coordinates of the same point again, yes? So x is 0, y is 1. This time this becomes 0, this becomes 2. 0 less than or equal to 2 is true. Yes, so it means that this should be considered this side. The side of this line containing this point. Okay, so on the one hand, I am on this strip, yes, between y equals to 0 and y equals to 1. And on the other hand, I am on this side of this line and above this line. So hopefully you agree with me. This is this domain. Okay, so what is clear for you? If you don't mind, let me give it a name. Let me change my color. For example, let me give this domain E. E is a little bit strange name, but it doesn't hurt, so let me call it E. Okay, so that is E. So I hope that now you agree with me that instead of writing this iterated integral, I can write integral of my function dA, but on domain E. Yes? So you see, I realize this one. from these limits I got my domain. I call that domain E. So I collect this back into its original form before iteration. It becomes this double integral but on domain E. Okay? So let us keep it like this for the time being and jump to the other one. The reason that I want to jump to the other one, I immediately realize that this is exactly the same integrand. The only difference is that I have a domain E. Here I have a domain D. Still, I don't know the connection between this domain and that domain. So this motivates me to find a connection between these domains. But this is simpler even than the previous case, because now X is between 1 and 2. So let me change my color. X is between 1 and 2. This is 1, do you remember? That was 2. So X is between 1 and 2. So I am in the strip here. But Y is above 1, so I should be above the line Y equals to 1. But I have to be below Y equals to X. Yes, so what is Y equals to X? Yes, I have to be below this one. So this is the domain D. So the author of the book has designed a nice question, because now you see that the domain of the first one is this E, but the domain D is actually this one. Yes, I hope that this is visible. So this is the domain D. Okay? But look, this integral, so let me bring this down here. Now you understand what is going on, hopefully. This is integral over D, and then Y over 1 plus X to the power of 3 dA. But I can write this as integral over L, yes, Y over 1 over X to the power of 3 dA. If you ask me what L is, I will tell you that L is the union of these domains. And of course, I know that the intersection is empty. So this is the language of set theory. If you're not familiar with that, doesn't matter. So if I give you the whole domain, including the green and the blue one together, it becomes a triangle. Okay? Assume that, and then I call this whole domain L. Assume that I give you this bigger triangle, and I ask you to calculate this integral on this bigger triangle. You can see that that bigger triangle can be partitioned into two disjoint parts, the blue one and the green one. So you understand that instead of calculating this integral, you can split it into two parts. Calculate the same integral on domain D, calculate the same integral, the same integrand on domain E, and add them up. Okay? But this problem is engineered in the reverse direction. Yes? They have given you two integrals. Your duty here is to collect them back. So this is what I did. I hope that you understood. So I just motivated you that this integral can be viewed as this integral on the blue domain plus that integral which is on the green domain. Because the integrands are exactly the same and the domains do not have any overlap at all, I can collect them into form of one integral where the domain is the union of these two, which is the bigger triangle. So the question mark of this question is the sum, which is still the same. So my question mark is still the same. But look, instead of calculating two different integrals and add them up, I can calculate a unique integral but on a bigger domain. That is the point of this exercise. And this is manageable. Do you remember? It was not manageable if I wanted to do it in that way. So let us see why. Okay, now forget about everything. Assume that this is a fresh problem. The bigger domain is given to you and you are supposed to calculate this integral. Again, your duty is to give the role of the free variable to one of them. I hope that you understand from the experience we had here, it's not a good idea to give the role of free variable to y. Yes, it is problematic. So let us try our chances for the other case. So I give the role of free variable to x this time. What does it mean? It means that I write that last integral as the integral, and then I put this. I put dx out. I want to give the role of my free variable to x because I realized the free variable y didn't work. Okay, now I come back here. And it is extremely simple. Why? Because this is your domain. If I give the role of free variable to x, then you need to answer this question to me. What is the minimum value for the x coordinate if I have a point somewhere in this domain? I hope that immediately you realize the minimum possible x coordinate is 0 if I am confined within this triangle. So the minimum value for x is 0. Okay, can you see what is the maximum? So the minimum is 0. What is the maximum? Okay, so this is my domain. Yes? So the maximum x value is 1. Yes? It cannot go beyond, sorry, it is 2. It cannot go beyond 2. Yes? So x goes from 0 to 2. Okay, and then you know that the inner integral would be an integral on y, the same integrand, of course, which is y over 1 plus x to the power of 3. Then you have to be a little bit careful about the domain, about the ranges or the limits of this integral. And that is the same trick that I told you. Because x is your free variable, you choose an arbitrary point here in your range. So let me bring this down. So I want to find, instead of going from 0 to 2, I pick one point somewhere, okay? So I, for example, choose this point, and I call this one x. Then I go vertically upward to see what are the y minimum and y maximum. So if I go up, this is y minimum, yes, and this goes up, and this becomes y maximum. Yes? Okay. And then I want to convince yourself it is always the same. You see, if I give you this x, the lower bound lies on this line, the upper bound lies on that line. This scenario does not change if I move x. So for example, if I move x here, then x minimum is here and it still lies on the same line as the previous minimum. And the maximum, the new maximum still lies. Of course, the new maximum is different from the old maximum, but it still lies on the same line that the previous maximum occurred. So hopefully, this is important to check that is it the case that this is happening for all choices in that range? If not, you have to split up the domain. But it does not happen, okay? So the minimum value of y is x over 2. I give you x, and I want you to read y minimum. Because this point is on this line, and I have given you x, you give me y is x over 2. And then what is the maximum? I have given you x, and this point on this line, so you give me y is equal to the same x. So the minimum value is x over 2, the maximum value is x. So the minimum value is x over 2, and the maximum value is x. So I consider this a nice problem, yes? Yes. Okay, so now I have to calculate the inner integral. Again, this is a y integral. So what is left at the end, I will call it integral, of course, but not integral of y, integral of x, because I am integrating over y variable. So x will be left. Okay, but you see that this integral is extremely easy to calculate. Let me just do that for you. So integral from x over 2, I want to calculate I of y, integral from x over 2 to x, but y is your variable, 1 plus x to the power of 3, as far as this integral is concerned, is just a constant. So if you allow me, let me pull it out immediately. It's 1 over 1 plus x to the power of 3 here. And then a very simple integral is left, y dy. And this is a very easy task to do. So I will write 1 over x cubed. This is a famous integral, so it is y squared over 2, but I have to calculate it between these two limits. The lower limit x over 2, the higher limit is x. So I copy and paste this factor here, and then I put x here, so it becomes x squared over 2, and then I put x over 2 to power 2 divided by 2. So it becomes x squared divided by 8. Let me double check. So I put x over 2 here. It becomes x squared over 4. I divide it by an extra 2. So that's correct. And then I make the common denominator. 4 minus 1 is 3. So this becomes 3 over 8, 1 plus x cubed, and then x squared. Yes? So if I calculate this, this is nothing except 8 over 8x squared. So 3 over 8 I put here, this I copied and pasted here, and then x squared is just there. That's correct. Yes? Okay, so this is my iy. Oh, sorry, I made a mistake. This is not iy, this is ix. So I put my ix back, and then finally I get my question mark. So the question mark is equal to integral from 0 to 2. Yes, instead of ix, I put this expression, but you see 3 over 8. So for some reason, let me keep 3 inside. You will see why. And then I have 1 plus x to the power of 3 dx. So I just put this into this, and then I factored 1 over 8 out, and I kept everything there. Okay, so this is also, I told you, this is a general trick. Whenever you want to calculate an integral and you get some part of the integrand whose derivative also appears as a factor there, it's indicating that take this one to be your new variable. So you see 1 plus x to the power of 3. If I ask you what is the derivative of that one, you will tell me 3x squared, and 3x squared also appears here. So this is already a good indication to take u to be 1 plus x to the power of 3. Of course, if you do that, then immediately you calculate the derivatives. du is equal to 3x squared dx. And now you understand why I didn't pull 3 out, because I need it here. Otherwise, I have to pull it out and then divide. Okay, and then what I do here, I find the new limits. So x goes from 0 to 2. This would then imply that u goes from where to where. If the lower limit is 0, I put it here, u becomes 1. If the upper limit is 2, I put it here, 8 plus 1, 9. Yes? And then I put this back to find my question mark. So the question mark is 1 over 8. Integral, instead of 0 to 2, I go from 1 to 9. Instead of 3x squared dx, I simply put du. And instead of 1 plus x cubed, I just simply put u. And hopefully you realize that's also a famous integral. This is ln of absolute value of a, so I have 1 over 8, and then I have ln of absolute value of u going from 1 to 9. Okay? And if I put 9 here, it becomes ln of 9, and if I put 1 here, ln of 1. ln of 1 is 0, so that is what is left for me is 1 over 8 ln of 9. So that's the answer. Of course, if you want, you can simplify it a little bit more. So 1 over 8, instead of 9, I can write 3 to power 2. And then you know that this 2 goes into the back. And then it becomes 2 over 8. But 2 over 8 has a better name, which is just a quarter. So the answer will be 1 over 4 times ln of 3. Okay? So this is our final answer. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.